One common question that we encounter often is whether to use a when to use a class and when to use a struct. So this is one very common question that is asked, and they look very similar also. Class and struct both look similar. They have similar looking things, but we always uh, find it difficult to understand when to create a class, when to create a struct. So this topic, this chapter or this tutorial is about how to make the right choice between a class and struct. Now here we have 3 points that we need to understand. Maybe you already know them, but it's on the basis of these 3 points that we should be able to decide, and in the end I'll give a summary also of what to use when. First is the memory allocation. One is created on the stack, the other is created on the heap. I'll go to the details of this in a moment. The second factor that we need to consider is boxing unboxing conversions, and the third factor is passing and returning from functions. These are the three factors that will help us decide when to use a class and when to use a struct. In the end, I'll give a summary also about uh, the whole thing that we shall be discussing. So first of all, let's talk about memory allocation. So I have written two these one is struct point. They are similar looking in text int y. Point 2, this is class in text int y. So on the basis of this, we shall be discussing the memory allocation aspects. So I'll take the code one by one. Suppose we write point p. Since point is a struct, this p will go on stack. Even if we used p is equal to new point, even if we used this syntax, in this case also p would have gone on the stack, and on the stack memory x and y would have been allocated. So this is one thing that is very clear. Whenever this is a struct, the memory allocation will take place on the stack. Whether you use this syntax or you use this syntax, the memory is allocated right at this point. So this is one thing. Now if you already know what is stack and what is heap, stack is actually a memory available to a thread. The allocation and deallocation is very quick. This is the fact that actually helps a stack to behave in a very optimal fashion. Although stack memory and your this heap memory, they both reside on the RAM. They reside on the RAM, but the only difference is that allocation and deallocation for stack memory is very quick. These steps are shorter, and therefore it is more efficient. But the stack memory is available to a certain limit for a thread, so we cannot create everything on the stack. Sometimes let us say we need to allocate 100 MB of data. Then in this case, obviously no one will use a stack. The object has to go to the heap memory. So stack is for shorter, smaller sized objects, and also for the objects that will live for a shorter lifespan. It's a sort of a scratch pad memory, a quick memory. So I'll come back to this again now. So now when we have your this point p, the memory is allocated on the stack, and now if the object is for a point point 2, that is it is for the class, then p2 also goes on the stack, but p2 will hold a reference. It is supposed to hold an address of a data that corresponds to class point p2. So p2 is not the class. This is not the entire object. p2 is not containing x, not containing y. It is containing a future address, the address of a future object of this class point p2. The object is going to be whenever it is created, it is going to be created on the heap only because this is a class and not struct. In the case of struct, as I've already told you, the memory is allocated on stack, but in case of a class, the memory is going to be allocated on the heap. But this p2 is a reference. It holds the address of a future memory. So in the next part of the code, for this p, we have set x and y both equal to 3. So x and y were already created, and their values have been now set to 3 each. So no memory allocation has occurred at this point. Then if we now write p2 equal to new point 2, then in this case the memory is allocated for point 2. Memory gets allocated for point 2. X and y are created, but this memory goes to the heap area, and on the heap area it will be a bit slower to allocate and deallocate memory, because heap compaction and many bookkeeping items have to be done. So in that case, heap is always costly, and in this case p2 will now, this p2 which was supposed to carry the address of a point 2, this p2 finally gets the address of the object. The memory is allocated at this point. So let's move next, and here we have written p2 dot x equal to 3, p2 dot y equal to 3. This means that this p2 is now finally initialized, or the values have been set, and we have started giving the values to this one. Let us now move to the next part, and here we'll summarize this part, that allocations and deallocations of value types are cheaper. These are value types because they contain their own heap, their own data, and this is ref type because they are allocated on the heap. These are called ref types, and these are value types. They contain their data, but the address of these is what is actually manipulated. So this is the first thing that we have taken. Now let's go to the boxing and unboxing conversions. Maybe you are already aware, but I'll still explain. Suppose we have a struct point. This has a data x, data y, and I have added a toString method so that we can print what is the data contained inside this point. So let's move further. Now suppose we allocate a memory for this point p. This memory is allocated on the stack, and we have set x and y both equal to 0. So this point p, this resides on the stack. We have already told this, and now let us suppose our project requires that we obtain a reference to this point p. Suppose there is some requirement, maybe we have to pass this struct to a certain function that expects an address, expects a reference. In that case, this p will be converted to a reference type, because object is a reference type, it is not a value type. Now the moment you create a reference for this struct p, this p is taken to the heap and memory is allocated on the heap. O will store an address of something on the heap, and because of this conversion, this simple looking code, this p is actually copied to the data inside this p is copied to a new object. So this is now a different object from this one. P also exists and this O also exists, but O is a reference to this point P on the heap, and the data matches because the object created on the heap is an exact copy of this P, This boxing conversion, it creates a new object on the heap, and the object's reference is now stored here. This means this simple step is actually creating a new object, and that too on the heap. So we have a cost also, and we have a new object also allocated. Now let us suppose after some time we have to get this point back from the heap. We have to get it on the stack. So if we write point p2 is equal to point o, the object on the heap will now be the data of the object on the heap will now be created on the stack and put into a new object called point p2. P2 is on the stack. The data of the object on the heap is now moving into this p2. So this is also a conversion, but in this case we have, first of all, we moved one data to the heap, then we have now brought back. So in this way we can say that we have point p2, we created this one also, and this one was already there. This simple object has led to two more objects being created, and the whole story is also going to the heap also. So this is about boxing and unboxing conversions. We can set any data, and if we write console.writeLine p, then this will be printed. And if we write p2, that is we try to print this p2, then 22 will be printed, because this p2 is a different object, that is a different object. So this is the code that you can run and check also. Let us now move to the third part, which is the returning and passing to functions. Whenever a struct is passed to a function, it is copied. A copy is created and passed to a function. This means if I have a object of a struct s, and if I pass it to this function, then like if I call it fs, then this s will be copied into this one. So original will remain the same, but action will not be taking place on the copy. So one thing is that these structs, they do not go modification when they are passed to a function. This is one thing that we should be aware. The second is that the entire data, whether it is small or large, the entire data has to be copied. That could be a costly affair if we create a too big struct. The next thing is that a class is a reference type, and only reference or address is copied. So if we have a class, let us say C, and this is, let us say, 100 MB large in data, and if we were to pass it to a function, then this 100 is not copied, only the address of this class will be copied. So classes are reference types, they are cheaper when they are passed to a function, but if we do any modification here, then the modification is actually taking place back home. So this is one thing that we should be aware. And now let me come to the summary. Use a struct when data passing is prime, not the functionality. So a struct will basically hold data. So when you have to create something to hold simple data items but not functions here, functionality, it's only basically a data capsule, a convenient putting together of data items. So use a struct when data passing is primary, and use a struct when total size is about less than 16 bytes. So developers, they recommend that it should be kept as small as possible. When it is about 16, 20, 24, around about, then in that case you should use a struct for small data, and use a struct when data is immutable, when you think that, when you want that the actual object should not change. In that case a struct would be preferred. because its copy will go. But again, it's your particular design requirement. Maybe it's quite possible that you do not want to copy a large object, and then there will be other ways of saving data, maybe create another temporary copy or whatever you do. But the point to note is that the struct's data will not change when it passes through a function. And the last important part is, do not use a struct if boxing unboxing will be frequent. These are the obvious things that you must have learned by now. So I'll close it right now. Thank you.